problem as dark matter is, even normal matter that we feel like we've understood for so long. What is matter?
What is matter? You know, when we do experiments like the Large Hadron Collider, we are smashing things together at very high energies. And I think the misconception is that we're breaking things apart and seeing what's inside of them, what's the littler bits. And it's simply not true. What we are doing by colliding things together at high energies is attempting to excite the vacuum of space itself. You see, quantum mechanics expresses the fact that particles act like waves most of the time. They propagate through space as if it was a wave. And waves are weird things that are spread out and have some inherent frequency to them. And when you want to look at something extremely tiny, you need to use light or a wave that has extremely tiny wavelength, because then you can resolve very tiny things. And so the Large Hadron Collider is in a sense a microscope which uses light, but particles. At such high energies, their wavelength is so tiny, it can investigate extremely tiny things. But instead of bouncing the light off of an object and letting it go into your eyes so you can see it, we're bouncing two objects off of the vacuum itself. And what comes out is a reflection, or more like a refraction, of what information is contained in the vacuum. And so particle creation that occurs at the LHC and other colliders is really energizing a little spot in the vacuum of space-time and seeing what it's made of. And all the stuff that comes out is a reflection of exactly that. So particles themselves are not inherent property. They're not fundamental because they can be annihilated and created. What is fundamental is the information living in the vacuum, and we call that fields, or at least that's the best description of them.